Hello guys, good morning. Welcome to another episode of Sound Talk Show. We are going to code Wolfram Language. I'm going to show you some interesting things about Wolfram Language. Let's see, mathematics, geometry, and Wolfram Language. So it's not technical, so any person can kind of enjoy it. So here is Wolfram. So here is some famous mathematical geometry objects. These are well known. You probably have seen it. Okay, I'm just gonna go through, and they are in Wolfram language functions, so you can plot them. Very interesting, and there's quite a few more. So I'm gonna add. So Wolfram language. Then there's a new ultimate hacking keyboard. If you are here, say hi. If you are watching this offline, play at 1.5 speed. Okay. So let's see. Am I like live? Check. Double check. Check. Okay, lower the volume a little bit. Check, double check. Okay, good. Keyboard, video, check. Okay, so Wolfram language, and there's a news about ultimate hacking keyboard. That's this one. So let me show you my keyboards. Okay, so there's some news. I'm gonna review them. So here I have a bunch of keyboards. So this is Glove 80 keyboard. Fantastic. It's my main for the past like 3 years. And this is Ultimate Hacking 60, or also known as Ultimate Hacking Keyboard 2. I use it as a macro keypad, so you can see I can switch to last application, or in browser I can switch to previous tab, next tab. Okay, you cannot see my screen. So anyway, Glove 80, this one, Ultimate Hacking Keyboard 60. This is Nulia trackball, and this is Logitech G502. Yeah, it's got a spin wheel. That's the best thing. Okay, so there is a new Ultimate Hacking keyboard coming out. So the one I have, Ultimate Hacking 60, it's wired. Okay, but the new one, so you can see I have a review for each one of them. Okay, on YouTube. In fact, more than one video, like 1 hour long for each one of these keyboards. So you can see this is my last written review for Ultimate Hacking Keyboard, and this is the first version back in almost 10 years ago. The first version is 2018. Okay, 2018 they came out with this Ultimate Hacking Keyboard. Now let me tell you about Ultimate Hacking Keyboard. They are the highest quality. Okay, now in many keyboards. Okay, if you are here, say hi. Okay, love to see your comments. In many keyboards, they all have high quality. So for example, I can tell you like the highest quality ones that I have. Okay, this, and I'm only talking about the ones I actually have. Like usually they give it to me and I used it for many months or years. So this one is Glove 80 is highest quality. Okay. And this sturdy metal, like very heavy Kinesis 360 keyboard is also highest quality. But here's the thing, they are high quality in different ways. Okay, the Glove 80, it's meticulous design, but however the overall thing. So let me show you. So can you like see? Let's see the video. So you see the overall is kind of like plastic, and but there's extreme meticulous design engineering when doing into it, because this Glove 80 many aspects. So you can go watch my video. I talked about them. So for example, this one, the Glove 80, they designed it so they want the key to be as low as possible on the table. Like usually if you put like, especially like oh god, so switch. So especially like switch. Okay, let's see, switch. Yeah, especially like the Kinesis 360. They are, if you put on the desk, like they're very heavy, like they are this high, and then your hand will be raised up like 1 inch from the keyboard. But the Glove 80, they want the lowest possible, so there's extreme engineering design went into it. And that's just one of it, one aspect of the Glove 80. What I mean by quality, okay, quality design. Okay, so there are many aspects of quality. That's what I'm talking about. So okay, so that's the can you see it? Yeah. So that's a Glove 80. Okay. Now on the other hand, the Kinesis 360 keyboard, they are built like a tank, like a like a tank, you know, heavy metal. Like they weigh a kilogram or something, 1.5 kilograms. Both? Yeah, both of them together. So this is also high quality but different. And also, so there are pros and cons. Okay, so right now my main is the Glove 80, but there are pros and cons. For some people, you might prefer the Kinesis 360, built like a tank, and also on-the-fly programmability. You can program the keys by just pressing a few keys on the Kinesis 360. That you cannot do on Glove 80. Like on Glove 80, if I want to change, for example, the right thumb key to be escape or tab, I have to go to the website, log in, you know, drag the key to create a key map, download a key map, then flash the firmware, which means you have to plug it in or something. Yeah, I think so. Plug it in and flash firmware, and so it's tedious. So usually you program it once, and you never usually you don't bother with it. So that's one aspect I don't like about the Glove 80, but of course it's got other advantages. That's why this is my main now. So on the other hand, the Kinesis 360 is dynamically programmable. If you just want, let's say experiment, you want the right hand control to be escape or whatever, you press 3 keys and it's done. It's burned into the firmware, programmable on the fly. But that only applies to wired version. Typically for wireless, that's impossible. Usually they don't have that feature. So anyway, so what I'm saying is the quality, there are different meaning of quality each one of these went into. Of course, there are some others. Some other keyboard, it's not high quality, but I'm talking about the high quality ones, okay? So then you got this. This is one of my favorite, the Expos. It's extremely simple. Hold on a second. Extremely simple, cheap, one piece, and every time I use it, it's a joy. You don't have to fiddle. You don't have to typically the 2-piece keyboards. You have to remap your keys, and you find that inconvenient. You want to change it or something. But the Expos is just simple. It's always been one of my favorite. Every time I use it, it's a joy. Okay, so the quality is in different aspect, and it's also very sturdy. It's this version Expos Night is built out of metal. So it's also metal. Okay, so then the Ultimate Hacking Keyboard is also of highest quality. Okay, now in particular about the Ultimate Hacking Keyboard, I have been using for by now 7 years. 2 different versions. Okay, so for example, right now I have the mouse. You see this is a trackball. Okay, and there's a add-on modules. I can show you. So I have everything written out on my website. You can see there's a separate page for add-on modules. So anyway, so on the Ultimate Hacking Keyboard, what they have. It's high quality. For example, I can tell you that one of the highest quality. Okay, my desk is all messy, so I can't just show you without fucking up my wires. But you see the feet, the snap-on feet. You can just snap on the design. Wait. I don't want to break it, of course. The feed you can snap on and off so extremely easily, but God. Okay, now this is embarrassing. So why can't? So there it is. It come off. It should, So it's well, I cannot show you the details. Can you see it? But anyway, in my video, you'll see the full demonstration. So just snap it in, twist it, and it's there. Okay, and you can pop up the feet. So that is a design element. You can take it off. You don't need screws or whatever. But one thing particular about the Ultimate Hacking Keyboard is that the guy, I believe they are like original. They are in Ukraine. I believe they are built in Ukraine or something around there, around Eastern Europe somewhere. I don't remember. But one particular quality is about software. They update their software like every year. Okay, so let's see. Ultimate Hacking Keyboard Agent. That's the software, and by the way, it's also open source. So you see, there's a update firmware. I don't want to do it now because I'm in the middle of a live stream. But can I show you? Yes, key cluster trackball. So let's see. Yeah, here's a trackball key cluster. What is my normal? Yeah, so here's my normal setup. The one particular quality about the Ultimate Hacking Keyboard is that the software is superb. Okay. Now, unlike the Kinesis 360, where you can just press a few keys without ever launching any software, but the Ultimate Hacking Keyboard, you have to launch the software. Okay. However, it is just extremely easy. You don't have to read any manual. Like you have to usually, configuring keyboard, you have to read the manual. Oh, how do you do that? But the Ultimate Hacking Keyboard software is just fantastic. Never has a problem. Everything just works. Okay, and they update it like every year. Every time you launch it, they tell you there's a firmware update. So if I say, for example, say update, it'll just update after like about a minute. I don't have to like unplug, replug, double check. Nothing. So it's superb. Okay, this and also the keyboard build quality. I'm not gonna show it today because watch my old videos. Okay, the build quality is just superb. Okay, like superb. Now the news is that, so I have reviews. I used to be a big keyboard reviewer for the past 15, 20 years, but I kind of stopped doing it because there's new keyboard every year. So anyway, so out of the so let's close that. So you can read, there are 1,000 articles about keyboard, mouse, trackball, everything. Okay. So there's a news about Ultimate Hacking Keyboard. So let's go to XR Code, xrd.info, my homepage. Then keyboard blog. Then there is news. Ultimate Hacking Keyboard 80 came out. Okay, this is fantastic upgrade. This is their website. So go to it. So this is the one. UHK80. So there's quite a few significant features addition. Okay, so first of all, you got the function keys now, which is kind of necessary for a lot of people, for me too. But then you got now four extra thumb keys. Okay, that's fantastic. This, can you see it? That is almost, that's significant. That's very significant for ergonomics. And also on the side, they have dedicated arrow keys and page up, page down, home, and that is also absolutely necessary. So I didn't like, the Ultimate Hacking before. It was kind of, it's one of those 60 keys. So you don't have dedicated arrow keys. You don't have dedicated page up and down. That's especially about arrow keys. That's a major issue for me. So now that's fixed in the Ultimate Hacking Keyboard 80. So that's fantastic. But plus you got page up and down, home, end, and function keys. So that would be fantastic. And plus it's wireless, finally. a lot of people need wireless these days. So it's it's USB wireless with the dongle, plus it's also Bluetooth wireless, and it can also be used plugged in while it's plugged in. So it's fantastic. So when you buy it, actually you can buy without the option of batteries. So meaning that you're gonna always use it wired. So you don't add the batteries, but it's still the same keyboard. Okay. So that is coming. They are sending me a unit with all the add-ons, I believe. So I'm gonna demonstrate that, and probably I will be using it for like a year or 2 or 3. Okay, so that's the news. Ultimate hacking keyboard. So anyone here? 3 people. Okay, say hi. So that's a news about ultimate hacking keyboard. Okay, and it's got tinting, fantastic. Okay, so that's about keyboard. Let's see. Now let's talk about math then. Okay. So Wolfram Language for programmers. If you don't know yet, you can use. That's the best programming language by a magnitude, and you can download it for free. Just go to xali.info, my website, this page. Search for XAL Wolfram Language tutorial for programmers. Okay, xali.info, and click on download. Be sure to follow this link specifically, because if you search the web, you'll be misled into some, other random pages. If you go to Wolfram Language website, wolfram.com, they have literally I believe they have like 1 million pages on their website, and there's lots of marketing material. So you have no idea where to find the download. You'll go with introduction or why Wolfram Language is the best, or other things. But if you want just to get a download and start it, easiest way is just go to my website, or the URL is wolfram.com/developer. Okay, so you can download it. Okay, and you can, I have over 100 Wolfram Language tutorials in the past. Okay, video tutorials. Each one is 1 hour. Okay. Without further ado, let's start to do today's what I want to do today. MeshRegion. MeshRegion is incredible. Okay. MeshRegion, they started to they added this feature about 10 years ago in 2014, Wolfram Language 10. Okay, so, and I've been studying it. I find it's not so simple. Okay, it's not so trivial. So I've been spending quite a few times in the past few months trying to read it. Because there are about over 100 functions related to this mesh thing. Okay, what is a mesh thing? Conceptually it's very simple. You guys all have seen it. Just like little triangles, mini triangles. They make a patch of a surface or something. For example, let's see, something like tetrahedron, this blob, or like a sphere, or this, it's a mesh. Like you often see it in the design of a car engine or shuttle, space shuttle, and so on, jet fighters and so on. But it's actually, so there's a lot to it. There's a huge amount of computational geometry. So, I've been reading it, it's complicated. So I started to realize they were designed 10 years ago, 100 functions about this mesh. So so I was a bit confused. Why are they doing it? What's what is the design principle? Why we have 100 things about the mesh? I mean, after all, it's like a bunch of triangles, right? So I traced it to, Wolfram Language version 10, 2014. So Stefan Wolfram has an article. He introduces the Wolfram Language version 14. So I read it, and I got an insight. Okay, so you can see my insight. Actually, I posted it on Twitter. But my Twitter has got lots of things. Let's see if I can find it. so basic, yeah. Well, I posted yesterday. So Twitter is kind of. Yeah, let me show you his article then. Let's see, Stefan Wolfram. Okay, Stefan Wolfram. Latest writings or writings. So 2014, so you go back 10 years ago. Each one of his articles takes many hours to read. Each one of his articles is actually a book length. And in fact, some of them are published as mini books, like, so each one of them takes several hours to just have a glance. That's the way his writing style. I mean, So 2025, 2024, so you got computational knowledge and future of pure mathematics. Okay, so there is Wolfram Programming Cloud is live, launching Mathematica 10 with 700 plus new functions and a crazy amount of research and development there. So in this article, he detailed about the reason for this mesh. Like there's a lot. This is the beginning of the machine learning era. Okay, like remember this is 2014. 2014 is around the time when the machine learning craze came up. So they started to have like machine learning functions built in. You can simply just say classify. It'll just tell you an element from data, from massive data of your own. So that's when they started to talk about the additions they have in geometry. Okay, so it turns out the mesh is complex. Simply put, is because they are trying to merge the concepts of the mesh from mathematics, the field of mathematics, and the field of 3D CAD design, like for engineers designing car engines, jet engines, and so on, CAD systems. So merge mathematics and CAD systems and computer graphics. So for example, so let me quickly, let's see if I can show you some example. So for example, this torus, that's a typical computer graphics, right? You might see it in game engine too. Or in game engine, anything you see is kind of like computer graphics. Okay, so computer graphics, there's, so in there you have the concept of points, line, triangle, or a patch, depending on, you have like, do they call it a patch? I don't know. But anyway, you have these concepts, point, triangles, lines, and so on, or maybe torus. So that's computer graphics. But in mathematics, you also have these concepts: line, point, plane, torus, or triangle. But the ideas in mathematics, this triangle, line, point, is very different from computer graphics. Okay, like in computer graphics, a point, like a two-dimensional point, is just two numbers. Okay, in mathematics, that's not just two numbers. That's the coordinate. They call it coordinate space, two-dimensional of real coordinate space. Real means real numbers, okay, which you cannot represent all real numbers in computer graphics. But anyway, mathematics point is very different. It's slightly different from computer graphics, okay. And then you have the CAD system, CAD engine. Okay, let's see. I can show some pictures. For example, design of a car engine. Okay, that's from CAD system. Now in the CAD system, you also have the concepts like point, line, triangle, but those concepts are very different from computer graphics in, let's say, in your typical 3D game engine. Okay, very different, because in CAD system they need to be very precise, and they have different needs. Okay, so basically mathematics, CAD system, and computer graphics, they all kind of share, they all have this concept of line, point, plane, or dimension, or triangle, a patch, or a surface, or a nerve, or a spline, or spline curve, or parametric curve. But they don't share that. But many of them are different for each one. So, but in Wolfram language, what they do is they unify it. Okay, so it's kind of So I read it. I realized, and that's actually the design. That's kind of the fundamental design principle of Wolfram language. Okay, so basically, you want to take the approach that you look at the word, doesn't matter what it is, history, programming, mathematics, or whatever, or esoterica, or anything human ever did in the world that we know of. Okay, and you want to create a whole map of them, a consistent way, in a consistent way. That is what Wolfram language is. Okay, so of course Wolfram language is a programming language, so it focuses on things related to programming language. So now back to our mesh thing. Why is the Wolfram language mesh like fairly complex? Because it's generalized. It's for computer graphics, such as we are plotting this torus or sphere. It is also for CAD, okay, and it is also for mathematics, okay. So that's why. Okay, so let me start to show you an example. Okay, so example, so MeshRegion. So let's see. Okay, so you got this mesh. So let's say MeshRegion examples. Okay, now that's what I want to show today. So these things. So for example, this one, Sierpinski This is typically called Sierpinski Triangle. Okay, so select all, paste, evaluate. Okay, so you can see, this is one of the first fractals. You break a equal angular triangle into 4. So for each side, at the midpoint, you mark it, and the 3 midpoints of each side forms a smaller equal angular triangle in the middle. So the triangle becomes 4 of them. Okay, then you repeat the process. So you take the top one as a triangle, you repeat it. So you got this sequence of triangles. So this process can be repeated to infinity. So you got kind of this fractal structure. Okay, and this concept, Sierpinski triangle, can be extended to 3-dimensional. So here is a 3-dimensional version. For example, let's enlarge this one. Okay. Okay. So here is the okay. So first of all, let me just show you the Wikipedia article. So there is Wikipedia article. Now this let's see. Do they have a pronunciation section? No. Okay. But anyway, let's say Sierpinski triangle. Okay, so this triangle, this kind of fractal thing, they are a concept in mathematics. Okay, this is very important. This is about why we were talking about the CAD systems versus the computer graphics systems versus the math. Okay, so in CAD system, you will never have this fractal thing. That's just that's for in 3D CAD system, maybe for visualization, maybe for toy or for drawing ones you have that. But for the ones that builds the engine, you never have that. You never need it. You don't want you don't need it, because you are never going to build an actual fractal that goes to infinity, right? So this wait, so where is it? This Sierpinski triangle, they are a concept in mathematics only. Okay, and in mathematics, then you have limits, you can find their area, you can find the length of the triangle, and so on. Okay, but that doesn't exist in CAD systems. And for computer graphics, yeah, you can do this. It would be very interesting if you guys try to draw this in Python or whatever, JavaScript. Of course, with Wolfram language, it's much easier. Okay, so that's one of them. So let's go to the next one. So yeah, so there it is. That okay. So there now here's another one. This one is called Menger Sponge usually. Okay, so let's paste the code here. Evaluate it. There you are. The idea is pretty similar. Okay. Kind of U factor. Okay, so let's go to the next one. This one is Cantor. Traditionally, it's called Cantor Dust. Okay, so you can. The idea is kind of pretty similar. So you start with a whole square, then you divide the square into 9 smaller squares. Okay, then you keep the ones at the corner, but in the middle you remove them. So one big square becomes 4 smaller squares. Okay, then you repeat it. It becomes 16 smaller squares. You repeat it and so on. And this Cantor Dust, originally it was applied to a line. So a line, you cut a line into 3 parts, 3 equal parts. You delete the one in the middle. Then you got 2 lines, on each side, right? So for each one of those lines, you repeat the process. So you got that, then you got that. You got smaller and smaller segment of lines. So this process should repeat to infinity, do this infinite number of times. The result is called Cantor Dust. Okay, so let's say Cantor Dust. You'll find it, or it's also known as Cantor set. So Cantor Dust, you don't, by the way, you don't want to use Wolfram Math Word. That website sucks. Usually is wrong too. So you want to Cantor Dust. So it used to be known as Cantor Dust, but today it's more like Cantor set. Okay, where is it? Wikipedia. Wikipedia Cantor Physical Road. What the fuck is that? Okay, let's search for Cantor set. Cantor Dust, let's say type math. George Cantor. Okay, so George Cantor is one of the great mathematicians. That's him. There, Cantor set. Okay, so Wikipedia will describe it. Let's see, stupid formatting. So let's just make it. Okay, they show you this. They show this. So this is one dimension. Cantor Dust was originally, it's one of the first exploration of the concept of continuity or density of a space or something in topology. Okay, so you got this weird space, it's not continuous. I mean, is it anyway? That's one of the first study. Okay, and so it can be generalized into 2-dimensional. So in 2-dimensional, you got this thing, and also in 3 dimensions. So you got this thing. Okay, so that's called Cantor set. Now remember, in Wolfram language, they all end with the word mesh. So again, in mathematics, they are not called mesh, they are a set. But why in Wolfram language they all became mesh? In mathematics, that doesn't make sense. That's not a mesh, that's a set. So it's a mesh because, remember, Wolfram language unifies this concept in mathematics, computer graphics, and 3D CAD systems. So because this thing, Yeah, it's a Sierpinski triangle. It's a topology space. It's a set in mathematics. However, in computer graphics, it's a bunch of triangles. You can plot them. And in CAD systems, you can actually build this too, like especially when you are doing 3D printing, just for toy. So the idea exists in all these fields, but you need a data structure that kind of can unify all of them. So that's why you got this mesh thing. So in Wolfram language, these things are called mesh because they are basically, the definition is basically it's very interesting, okay? Actually, the definition is called, also exists in math. It's called simplicial complex. Okay, there. Simplicial complex. That is kind of fairly advanced, okay? So a complex is basically like a point, a line segment, a triangle, or a tetrahedron, or in higher dimensions or higher, So basically, they are the minimum kind of elements that occupy the dimension, okay? So they're simplex, so like these are simplexes. In 0 dimension, it's a point. In 1 dimension, it's a line segment. In 2 dimension, it's a triangle. In 3 dimension, it's a tetrahedron. In 4 dimension, it's a, how do you call it? I don't know, but it's like, in 4 dimension, you got one, then you got in 5, 6, 7 and higher dimensions. So all these things in general, you call them simplex, okay, in any dimension. So that's simplex. Now what is a simplicial complex? That's basically a set of simplexes, okay? A set of simplexes that may be connected together like this, okay? So this idea applies in any dimension. So this is a math idea, and that idea is basically the fundamental unifying idea of the Wolfram languages, what they call MeshRegion, okay? Do you guys understand? Like, maybe not, I don't know. Okay, so anyway, so all these meshes we are seeing, Sierpinski Triangle mesh, or the Menger Sponge, they call it mesh, or the Cantor mesh. They actually all return this. They all return this mesh region. So for example, I can show you. So for example, this, okay, so let's say, is that there, x, okay, so wait, x equals to Cantor mesh, Cantor mesh, so you want to nest 3 times in dimension 2, let's say dimension 3, okay? There you go. So let's not nest too many times. Let's nest it just 2 times. So nest it just 2 times. Okay, you got this thing. Okay, let's say 2, 3, 4 times. Oh, okay, that's interesting. And you can now say, you see, it returned this huge list. There are 32,000 stuff points in it. So, but the whole thing is a mesh region. So, all these, their return value is this mesh region. Okay, that is that interesting. Hi, hello, simple postman. Let me get my coffee, and maybe that's it for today. Simple postman says, let's magnify. So control, and I assume that in practice, if wait, yeah, this annoying I assume that in practice, a full-scale CAD system written in Wolfram language would be very slow. So even though it's admirable that the concept of line act or unified application is doubtful, that's not correct. Okay, but let me answer that. Let me tell you. So how detailed and precise can a 3D image be in Wolfram? I never used it beyond math homework. Okay, then he says I've just got Googled Wolfram system modeler, so probably I'm wrong. That's right. That's right. And there are real-world systems for 3D simulations and CAD in Wolfram language. Yes, that's true. So that's what I'm saying. So if your job is a professional, let's say, drafter, or like there's a job, all this computer CAD used to be drawn by hand, like back in 1990s when I was at De Anza Community College. There's a course, there's actually a major, I think, actually a major to be a drafter. And I was very much interested. I was, about to become a drafter because I was fascinated by this, drawing of engines or space shuttles. Okay, so for example, CAD space AutoCAD, there are many. So before computers, all these are actually done by hand, but maybe not as detailed as this one. But you gotta do this for gears, simple, or bicycles, lots of things. So I was So what was I gonna say? So what I was saying is that, so if your job is like professionally creating these things, then obviously you need a dedicated CAD software such as AutoCAD. There's quite a few. I have actually a lot of articles about that. So let's search. Let's say CAD. Let's see, computer CAD systems. Okay, so 3D CAD, no. Math models and 3D input. Okay, so these are my very old articles. Mathematical graphics with live graphics 3D, that's like 20 years old. Relies on Java, that no longer works. Okay, because Java plugin on the browser, that's gone. So let's see. 3D visualization design. Wait, what? Okay, let me just find the article. 3D visualization design. Okay, that's like, this is old article. Requirement for a visualization system, 2010. Outline rendering 3D models. What is technical drawing, descriptive geometry, and projective geometry, and linear algebra? What are the differences? Math models of 3D input control. Okay, so let's go back. Mathematical optimization problem. Okay, so let's see. So here is another interesting thing. Like usually when we see cartoon, they are drawn like that, or this image. They are not. It's very interesting because in order to draw this, you cannot just rely on a 3D model. You need to have a 3D model, then you need to have a 2D projection. Like you need to project it on a plane, then figure out, find the like convex hull. So anyway, so it's not a pure 3D thing. So very interesting. So as also, for example, this thing you see, that's a screenshot in Second Life. So it's showing this cartoon character. This is a Monopoly boss, the character, but it's in 3D because in Second Life, the guy actually moves, but the way you see it is only 2D. You see, so what's happening in this kind of thing is that you got a 3D thing like that. For example, we did this live, and so for example, I can show you. So paste it, There it is. There it is. Go down. It's computing, so go down, wait. What? Okay. Okay, okay, that is incorrect because I defined the x. That's what screwed it up. So I need to undefine x, okay? Clear x, okay? Then let's run this. Okay, so you see you got that, and then you got that, then you got that, then you make it thicker, then you got that. So this is a computer graphics 3D thing. Then once you have this, then you need to project the whole thing into a 2D plane. Then you take the outline. So in this case, the outline is like something like that, okay? So in fact, let me show you something interesting. So for example, let's, I'll get back to your question, but actually you already, you already know the answer. You got the answer. But so let's capture this image. So we got a 2D image. Now, how do you import a 2D image? Can you drag it? Let's see. There it is. So there it is, okay? Now, Shift Enter. So wait. So now, let's say X image equals to there, okay? So X image is now a raster image, okay? Now let's use that one of the mesh to turn that into a mesh, that like the thing we are talking about today. God, do you guys are still following me? Like we can turn an image into this, which is, let's see, because I was trying to do this subdivision mesh, okay? The Delaunay mesh, that's very interesting thing we haven't done yet. Voronoi mesh, convex hull mesh, array mesh we haven't done yet. Image mesh, okay? I was wondering, it's turning a image into this, I assume it's a 3D thing, so I have no idea. So now it's a good time to try. So let's see. Image mesh, not multiply, image mesh. Okay, now X image, let's see what it returns. There it is. So you see, it returns the outline. Fantastic. You see, it takes an image. The image is basically a 2D projection of this. You see, this is 3D, but once we take a screenshot, it becomes a 2D image, basically a projection. Then you say image mesh, that turns it into a kind of outline, okay? So which brings up what we were talking about the, can we go back? About this, outline rendering of 3D models. Anyway, we digressed. So basically what I'm saying about that, can Wolfram Language do CAD, is that if you are a professional programmer, if you are a professional CAD, designer, then you use dedicated CAD. But for engineering, if you are designing a car engine and, something, oftentimes you need to solve equations, you need to output models, then you export, you see this idiotic website, ANSYS space claim. So you can design it in Wolfram Language with very precise, CAD specification. Then you output to, one of the 10 CAD system formats. Then you import into the CAD system. Then you can further do whatever you want to do with it. Okay, so what is this website? So let's refresh. That's one of the problem of modern websites. When you don't have JavaScript, it's still stupid. Okay, it doesn't work. But the graphics become fuzzy because I don't have cookie on, Anyway, so all these are CAD stuff. There are so many. So what I'm saying, yeah, if you are a professional CAD, maybe you use a CAD software, but oftentimes you need to do a lot of equation solving stuff, to get it right. Then you can do it in Wolfram language. Then eventually you get some kind of thing like that. Then you can export it. Okay, now the website looks good. Accept all cookies. Oh shit, fuck. I'm gonna every time I quit, it'll delete all cookies. So this is another 3D modeling software. Okay, so that's what we are talking about. So, but if you are a Photoshop, professional designer for website, that applies too. Like typically you use Photoshop, right? But in Wolfram language, you can do basically anything you can do with image processing. So for example, image, there's like whole ton of image processing functionalities. So let me go to it. Okay. So if you go to the Wolfram documentation, okay, so graphics, images, okay, so image computation overview, you can do like just about anything, everything. Photoshop needs to do, and NASA, they need to process, photos taken from Mars or whatever. Okay, that's so So what I'm saying, yeah, so you can do just like anything that is possible with a computer. For me, programmers, I'm into geometry, so that I do a lot of these kind of thing, and also do lots of like text processing, things like that. So anyway. Okay, I think that's it for today. Thank you guys for watching. Yeah, actually there is something I need to do. Okay, so let me finish them. Okay, save this today. Okay, and there is more things I want to do. Okay, so mesh regions, did we finish demo? No, not yet. For example, this Delaunay mesh we haven't demoed yet. That is very interesting because what it does is, why can't I paste? Oh, because I got function key in. Okay, now paste, shift enter. That's so you give it like 50 random numbers. Okay, this part paste return let's say 5 random numbers. So this means give me a random number between -10 to 10 and give me 5 of them, but in group of 2. Okay, so shift enter, there you are. So now do the same. Let's say give me 10 of them, but however feed the input into the Delaunay mesh. Okay, so do that. It generates a mesh. Now so you basically got a random bunch of numbers, and it create triangles among them in a particular way. That is related to Voronoi triangle. Okay, let me show you that. But anyway, but here you can also do it in 3 dimension. So this time we got a bunch of random numbers, 50 of them in groups of 3. So each 3 points is, each 3 numbers is a point in space. So that's this input. Then create the Delaunay mesh, then highlight some part of it. So let's run it. So there you have it. So the vertex are colored red, the line segments are colored blue, and the faces are colored, light blue and transparent. So you can see semi-transparent. So let's say change opacity to 2, so much more transparent. And let's change too many points. Let's change it to just 10 point. Shift enter. So there you have it. Okay, and there's a lot more. So I wanted to demo Voronoi mesh. That's very interesting. Okay, so let's go to, okay, so let me just do a few more. Okay, so you go to geometry and mesh-based geometric regions. So what I have been reading is all this geometry in the past month, especially basically this and this and these three, these two, mesh-based geometric regions and derived geometric regions. This like there are 100 functions just in those two sections. So here we covered most of it already. Let's magnify. MeshRegion, then we cover that. So let's do this one. Okay, Voronoi mesh. And you can have it in 1 dimension or 2 dimension. Okay, let's just copy it. Okay, you have to copy it. So show in browser. So that is what I'm doing, and now. So now a new section. Okay, and what is the thing we are doing? This is called Voronoi mesh. Okay, and the function is that make a Wolfram language reference link and start a Wolfram language code, pop it out, and that returns a list of random numbers, 25 of them. Okay, and then what you want to say is just that random numbers. Okay, so remove that. So ellipsis, we don't want ellipsis. Yeah, so actually we don't want that, just put it here. Okay, so that will do it. So this is a 2-dimensional version. Okay, and we can also have a 1-dimensional version. So here you don't say that. Okay, that's 1-dimensional version. So let me show you. So go back to Wolfram language, paste, run it. No, that didn't work. Oh yeah, because you forgot to say how many. So you want, let's say, 20 of them. Okay. No, that didn't work. Maybe you need to do that. There it is. Okay, so each time it generates a different one. And so that's 1-dimensional case. And so let's do that one. And here is 2-dimensional case. Okay, fantastic. Okay, now it's like missing something, because usually this diagram is shown with a dot in the middle. Okay, so that's easy to do. So let's just Yeah, that's why it says points equals to, so those are my points, and then mesh equals to that. Then what we're gonna show is we're gonna show show the mesh, plus we want also to show points. Okay, so what we can do is okay, so it should be just wait, so let's make it red. Yeah, let's see. Okay, that's not right because you are missing graphics. There it is. So the red dots are the original random points, and the Voronoi mesh is created that it creates a line between any two dots such that the line is like in the middle of them. So that's how this this is formed. Okay, so if you want to know the details, you can just search for it, Voronoi diagram. Okay, and there's a JavaScript. This is very interesting. There's a JavaScript application out there that allows you to, you know, click on several to create random dots and drag the mouse, and it'll show you change in real time. Okay, I think that's it for today. Working on a CAD system, you know, that's difficult. You know, you've been working on a 3D game engine in Lisp. That's very difficult, 3D game engine, and you also been working on a CAD system, so that's also very difficult. Okay, bye guys. Interesting stuff. Thank you. Yeah, that's it. Bye. So we shut down in 1 minute. So this is working code. Yes. So put it back, and syntax correct, showing browser. Then we're gonna add, so we need to add the graphics, add this graphics there. And I myself need to spend many hours or days to study many of these. But for example, this one, you know, the Voronoi diagram, I never actually read, you know, the algorithm. How do you actually do it? You know, because this is not easy, not trivial. Okay, because you need to create these dividing lines. In order to create the dividing lines, basically you need to find these other points. You see, so given a bunch of random points in a plane. By the way, this also can be in 3D. We didn't show, but you can do it in 3D. Just like this Delaunay triangles. Okay. In fact, they are the opposite of each other. They are the what they call dual. Okay. So Voronoi triangle dual is the Delaunay mesh. Okay. So in other words, this given a random bunch of points in the plane, you want to find another bunch of dots in the plane such that when you connect the dots, they divide any two neighbor random points in the middle. Okay, so, and those new points you created, those are actually this Delaunay mesh points. Okay, so they are dual. So, but given a random list of points, how do you find the other points? That's not trivial, because then for each point you have kind of check all the other points. Then you compute their distance. Like you compute their distance divided by half. Then you compute the vector, so you get the midpoint between them. Then so it is this huge amount of computation. So what is an efficient algorithm? So I never actually thought about it. I got a book like 30 years ago, but I never actually read. So I'm going to, today, this week, next week, I'm gonna start to like look into these algorithms, how they do it. Very interesting, and very beautiful. Okay, so you see the dual graph of Voronoi diagram, blah 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 blah, corresponds to the Delaunay triangulation for the same set of points. So it mentioned there, so you can see their relationship. Okay, bye. Oh, but besides studying this, so there's a lot more, because of Wolfram language. You can see, I already spent like several days to read about this whole mesh thing. Why is it called mesh? Then many of these, for example, this Cantor mesh we showed, they are mathematical ideas in topology. So you want to, so then you stop computer graphics, stop programming, you go into mathematics, which is pure mathematics. Then you learn about this. For example, I don't exactly know why is Cantor Dust created in the first place. I know it's related to study like the density of the space or something, like point set topology. So density. So Cantor mentioned this ternary construction only in passing as an example of a perfect set that is nowhere dense. Okay, so this Cantor Dust thing, in the case they are talking about, that's a one-dimensional version. Okay, so just one-dimensional, so line segment. So this set is such that it's nowhere dense. So that's pure mathematics. Very interesting. Okay, so yeah, so these kind of things, the Wolfram language, when you study them, there's like huge amount of things you can study. And also another thing interesting we talked about is that, you see, how exactly do they merge the concept of mathematics, the concept of computer graphics, such as computational geometry, such as this Delaunay mesh, Voronoi mesh, convex hull. They merge with mathematics, and then like, did they do it right? Like, how do you look at all these topics in a kind of unified whole? So that's what I have been doing. Bye.